Hello everyone, welcome back to this Unity tutorial series on how to create a roguelike like Vampire Survivors. So as we all know, game managers play a vital role in any game, and Vampire Survivors is of course no exception. They are scripts or components that control and manage different aspects of a game's behavior, also serving as a central hub for coordinating and managing various game systems and components. A solid game manager is a must-have and is crucial for ensuring that the game runs smoothly and consistently. So, in this part, we'll be going through the process of constructing a reliable game manager that is not only responsible for managing the game states, but coordinating the various game elements and of course tying all of the systems we have developed so far together. And along the way, we'll also be implementing some important UI features to give the game some flair and life. And by the end of this part, you should have something like this, which is a game manager that is able to change states, you have the pause state, which is the pausing and resuming feature, and you have the pause screen, and on the pause screen you have a display of real-time stats. You also have the game over state. So the game over state shows the result screen, and on the result screen you can see the result screen information, which is stuff like the chosen character sprite and name, level reached, and so on and so forth. And without further ado, let's begin. As with every part of our tutorial series, I'll first begin by introducing our approach. So for the game manager, we'll be using a behavior model known as the finite state machine, or FSM for short. If you're not familiar with the concept, let me explain. So a finite state machine is a way of organizing and managing different states or modes within a program. In a game, a FSM can be used to manage various game states such as the main menu, gameplay, pause menu, game over state, and much more. Each state will have its own unique behavior and rules, and the FSM facilitates the transition between these states. By using a FSM, we can create a flexible and robust game manager that handles the game's various states and systems with ease. With this approach, we'll be able to build a game that is easy to understand and maintain its code while providing an enjoyable experience for the players. So first, let's start by creating a new C# script in the scripts folder and naming it Game Manager. You'll notice that the Game Manager script has a unique gear icon which sets it apart from regular scripts. This is because the Game Manager is a special script name designated by Unity. Unity has several such special names such as Search and JS Script. These names, however, don't have any impact on your game, so there's no need to worry. I brought it up because I thought it was an interesting trivia that some of you may not be aware of. Now, let's return to our main topic and open our Game Manager script. To create a finite state machine, we'll first need to define an enum. If you're not familiar with enums, let me explain. So, enumerations, or enums for short, are a data type that contains a set of named values. They are often used to define a limited set of options or choices that can be used in a program or game, making the code more readable and maintainable. In Unity, enums are frequently used to define the different states or options that a game object can have. For example, you might want to define an enum to represent the various states that a player can be in, such as idle, walking, or jumping. By defining or using a limited set of options or choices, basically you can help prevent mistakes or errors by limiting the possible values that can be used. So there's much more to enums than I just explained, so if you like a more comprehensive guide on enums, Unity actually provides an official tutorial that covers the topic in detail, so I recommend you check it out. Now let's define an enum for our game manager. To do so, we need to use the enum keyword followed by the name of the enum and the list of possible values that it can take. We will call this enum GameState and define it with 3 values, each representing a different state in our game. Did you notice how I used the upper camel case instead of the lower camel case when defining the enum and its values? Well, this is actually a common convention practice in C# that helps to distinguish enums and their values from variables or methods, which in turn can actually help to prevent naming conflicts and make the code more readable. And now that we have defined the 3 basic game states for our game, we can easily add more states in the future by simply adding them to the game state enum. Moving on, let's declare a public variable of the game state type called current state. As the name implies, this variable will be used to store the current state of the game at any given time. So if you head back into the editor and add the script to any one of your objects in your game and look at the component, you'll see that the current state variable is actually shown as a drop-down when you click on it. The drop-down displays the different values of the game state enum. Don't forget to remove the script from the object before moving on to the next step. Alright, so back in our game manager, let's create the update method to manage the behavior of our game manager based on its current state. For this, we will be using a switch statement, which is a control structure that evaluates the value of a variable against a set of possible values and executes the corresponding code block when a match is found. Now, this is the reason why switch statements work particularly well with enum types, because if you remember what we've discussed before, enum values are essentially a finite set of constant values. This makes it easy to define a case for each possible value and handle them in a clear and organized way. To use a switch statement, we just need to follow these few steps. First, start with the switch keyword followed by a pair of parentheses containing the variable we want to compare. In this case, we're trying to compare the current state variable. Now, inside the curly braces, add a case statement for each possible value of the variable that we want to handle. Make sure to add each case block with a break statement at the end to exit the switch statement. Otherwise, the code will continue to execute the next case statement and then the next case statement after that and then the next case statement after that until the end of the switch block or until a break statement is encountered, which is what we don't want. Lastly, inside each case block, write the code that you want to execute when the corresponding value is matched. Before we proceed, let's also add a default block to our switch statement to handle any values that don't match the case statements. Now, although this block is optional, it's good practice to have it for error handling purposes. Inside of the default block, we can add a debug.log warning line to notify us if the current state changes to an invalid state. Now, let's perform a test to make sure that everything is working properly. We can create a function that cycles through all the different states of the game. If you're unsure as to how this test function actually works, just remember that an enum is a set of named integer constants, and because of that, incrementing and decrementing works. Back in the editor, to test our game manager, assign the script to any object and hit play. When you press E or Q, you'll notice that the current state changes. However, if you increment or decrement beyond the defined range, you'll notice that the current state becomes blank. Why is this so? Well, if you exceed the defined range of an enum value, it can actually cause unexpected behavior. In the case of Unity's inspector, the enum field becomes blank because it's trying to display an invalid value. The debug.log line that we set up in the default block will also appear in the console, notifying us of the invalid state. Now that we've tested our game manager structure and we ensured that it works, we can remove the script from the object and remove the lines used for testing. Our script structure is now complete and ready for use. Great! With our game manager structure in place, we can now add functionality to the different game states. We'll first begin with the pause game state. So our first task will be to add the functionality to the pause game state, which will be starting with the ability to pause and resume the game. If you're already familiar with time in Unity, you know that the easiest way to do this is to set the time.timescale to 0 to pause the game and back to 1 to resume it. This is because time.timescale is a float value that represents the scale at which time is passing in a Unity scene. A value of 1 means that the time is passing at a normal rate, while a value of 0 means that time is effectively stopped. To achieve this, we need to create two methods, pause game and resume game. In the pause game method, we need to do the following. First, we set the current state to paused. Next, we set the time.timescale to 0 to pause the game. And third, we add a signal by using a debug.log line to signal that the game has been paused. Next, we will implement the resume game method to resume the game from the pause state. Similar to pause game, we will need to handle the game state and the time.timescale. But before that, let's declare a variable named previous state of type GameState to store the previous state of the game before it was paused. This variable will come in handy for other functionality later down the line. To prevent errors when resuming the game, we need to make sure that the current state is not already paused before calling the method. Therefore, let's wrap the entire code inside an if statement that checks if the current state is not already in the GameState.pause state. It's important to check if the current state is not already paused because calling the resume method while the game is already paused will cause issues when trying to resume the game later on. So by checking if the current state is not already in the pause state, we can just ensure that the method will only be called when the game is in a so-called unpaused state. Inside the if statement, we'll set the previous state to the current state. Now, let's move on to the resume game method. Firstly, let's check if the current state is paused since we only want to resume the game if it's in the pause state. Next, change the current state to the previous state that we stopped previously, and afterwards, let's set the time.timescale to 1 to resume the game. Finally, add a debug.log similar to how we did so for the pause game method as an indicator. To clarify why we reverted the current state back to the previous state, it basically just ensures that the game continues from the exact point when it was stopped, preventing any unexpected behavior that could potentially break the game's logic. For instance, if the game was paused, let's say during a power-up state when the player is, well, invincible or something, and then resume without reverting the current state back to the previous state, the game might continue from, let's say, the gameplay state, which is not what the player expects. The player would expect to continue from the same point after resuming the game. Thus, by reverting the current state back to the previous state, the game can just continue from where it left off, providing a consistent and seamless experience. Before moving on to checking the input for pausing and resuming, let's make a small improvement. Instead of constantly using the equal sign or the assignment operator to change the current state, we can create a method called changeState. This method will basically just take in an argument of type GameState, which will be the new state that we want to switch to. By using this method, we can just encapsulate these state changes and have far better control over them. With a separate method for changing states, we can also easily track where and when we are making the state changes. This provides more clarity and organization to the code. To check for the pause and resume input, we can first create a method called check for pause and resume. Here's what it should do. Firstly, it will check if the escape key is pressed and if the current state is paused. If the current state is paused, call resume. Otherwise, it will call pause game. Make sure to call this method in both the gameplay and pause states to ensure that pausing and resuming can only be done in these states, avoiding any accidental pauses during game over or even accidental resumes. Now it's time to test our changes. To do so, let's create a new empty game object in the game scene called Game Manager. Reset its transform and add the Game Manager script to it. Then hit the play button from the menu scene and wait for the enemies to spawn. Once they do, press the escape key and they should now freeze. Additionally, you should be able to see in the inspector that the current state has been updated to paused. You can also check the console to see the indicators we set up using debug.log. Now that we've implemented the pausing and resuming functionality, let's create a pause screen to go along with it. Start by creating a public game object called pause screen in the Game Manager script. Then, in the pause game method and the resume game methods, we can simply enable or disable the object to show or hide the pause screen. To ensure that the pause screen and all other future screens are disabled when starting the game, let's also create a method called disable screens and disable the pause screen within it. This will be useful when we add more screens later on. We'll also call this method in awake to make sure that it's disabled when the game begins. In the editor, create an empty game object under canvas and name it screens. Set its anchor by holding the alternate key and clicking the bottom right option to stretch it to the entire screen. Next, create a panel under the screens object and rename it to pause screen. Next, drag the pause screen to its slot in the Game Manager component. Now, when you start the game, even without disabling the pause screen, you can see that it automatically disables. And when you pause and resume, it should appear and disappear accordingly. However, pause screens usually have some options such as restarting the game or quitting to the main menu. So let's create some UI for the pause screen. First, give the pause screen a grey tint and increase the alpha to 200 to dim it. Next, create two buttons under the pause screen and name them to quit and resume respectively. Set their text to match their names and space them out nicely. I'll anchor both of mine to the bottom of the screen. And now your pause screen should look something like this. Now create an on-click event for each button. Add the scene controller script that we made a few parts ago to the Game Manager object and assign it to the quit button's on-click event. Select the scene change method and pass in the name of the menu scene. As for the resume button, drag the Game Manager object into the on-click event and select the resume game method on the Game Manager script. Now, when you play the game and pause, if you click the quit button, you'll be sent back to the menu scene. And if you click the resume button, the game will simply resume. Great! Let's now discuss an additional feature of the pause screen in Vampire Survivors, the stats display. So when the game is paused, players are able to view their stats in real time. This can be helpful in tracking progress and planning future actions. Please note that we'll only be focusing on the basic pause screen for now, without additional elements such as the map or the arcana. Before we proceed, let's think carefully about how we want to implement the real-time stats feature in a performance-efficient manner. Simply checking for changes in the player stats during every update call would be far too processing intensive, so we need to think of a more efficient approach. One option, if you recall, is to create properties in our player stats script, which allows us to encapsulate variables and, if you recall, allows us to add custom logic to their setters as well. This is extremely important because by doing this, we can actually track the changes to the stat values after setting the value. Let's begin by creating a property for current health in the player set script with additional logic in its setter. Now, you might be wondering how this all works, so allow me to explain. The get block simply returns the current value of the current health. The set block is where the magic happens. Whenever a new value is assigned to the current health, the set block is executed. The if statement checks whether the new value being assigned to current health is different from the current value stored in current health. So if the values are different, it means that the value is being modified. So the code inside the if statement is executed. The new value will then be stored in the current health, replacing the old value. Using this approach, we can update the UI in real time every time the value of a stat changes. Additionally, any additional logic that needs to be executed when a stat changes can be added inside the if statement. Let's repeat this process for the rest of the current stats. Now, some of you may be wondering why we are using properties instead of methods to modify our current stats. While methods are certainly an option, using properties allows us to add additional logic to the property setters, making it easier to track the changes in the stat values and also update the UI in real time. Using methods, on the other hand, would require accounting for various scenarios such as multiplication or division of stats, and modifying the function every time. This can quickly become a hassle and create unnecessary complexity. Now comes the tedious part. With the use of properties, we need to replace all the references to the old stats with the new properties. Yeah, so there's not much to be said here, you just need to find all the instances where the current stat is used and then you can replace them with the properties. If you're on Visual Studio, you can simply right click on the stat and select Find All References. Make sure to follow along closely and pay attention to the script names as it can get confusing. Alright, so although that was extremely tedious, it now makes it easier for us to check where the value is being called at. And now, since we don't have a need for the public keyword for each of the current stats anymore, we can remove them along with the hide in inspector attribute to minimize confusion. Before we move on, let's make sure everything is working as intended by heading back into the editor and hitting play from the menu scene. After that, since we've added a lot of properties to our player stat script, it's also a good idea to organize them with a region. So what is a region? Well, this preprocessor directive in C# allows us to define a collapsible region of code which doesn't affect the code functionality but can make it easier to navigate and manage related code. To define a region, simply start with #region at the beginning of the code you want to group and end it with #endRegion. You can also give the region a name by typing it after the #region. I'll name my region current stats properties to make it clear what it is when collapsed. Now, you should be able to collapse and expand your code. I should also mention that although regions can help with readability, they can also be overused and lead to excessively long scripts, so use them at your own discretion. Before we move on, let's verify that the system that we've set up actually works. We can do this by adding a debug.log statement to the if block that checks whether the value of the current stat has been changed. To test it, let's check with the current move speed property. Head back into the editor and hit play from the menu scene. Once the game is running, upgrade the wings weapon. If you look at your console, you should be able to see the debug.log line that we just added, indicating that the value of the current move speed has changed due to the wings passive item upgrade. Now that we have verified that the property works as intended, we can remove the debug.log line since it's no longer necessary. Next, let's create some UI for the current stats. Under the pause screen, create an empty game object called current stats display and anchor it however you like. In my case, I'm anchoring mine to the left to make space for additional UI in the future. Now to position it exactly like mine, you can just follow my values. Now, create a text object as a child of the current stats display and change its color to white for better visibility. Duplicate this text object 5 times as we have 6 stats to display, and rename them accordingly. Set the text of each of the text object to the name of its corresponding stat. For instance, the first text object should be named current health display, and the second should be named current recovery display, and so on. Finally, add a vertical layout group component to the current stats display to automatically sort the text objects. You should now have a display that looks similar to this. Inside the Game Manager script, let's begin creating some variables. Since we are working with UI, let's first begin by adding the Unity Engine.ui library. Afterwards, create text variables for the different stats. Now, before we proceed with the linking of the variables to the properties that we created in the player stat script, let's make our Game Manager script a singleton. So as we discussed in an earlier part, A singleton is a design pattern that restricts the instantiation of a class to a single instance and provides a global point of access to that instance. Now, there are two main reasons why we're applying the singleton pattern to the game manager script. First, it allows us to access the game manager without having to create a reference. Since the singleton provides a global point of access to its instance, other parts of the system can reference it directly without the need for passing around references. Second, it helps to ensure that only one instance of the game manager is running at any given time. Now, this is particularly useful in our game to avoid any conflicts that might arise if multiple instances of the game manager were running simultaneously. But now, some of you may be wondering why we're not using singleton for all our scripts in the project, which would eliminate the need for direct references. Okay, so while singletons can be helpful in certain situations, they can also have some drawbacks. One potential issue is that they can create hidden dependencies, which basically means that you don't really know what the script relies on, which can make it challenging to manage and understand the behavior of the code. Additionally, testing code that relies on singletons can be difficult, and they can limit the extensibility of a system. Therefore, instead of relying solely on singletons, I prefer using direct references such as findObjectOfType and getComponent. However, if you do choose to use singletons for multiple scripts in your project, keep in mind that they should only be used when there is a genuine need for a global access to an object and when passing it around as a parameter isn't practical. Don't just do it because you're lazy. Additionally, make sure to also consider the drawbacks of using singletons, such as the hidden dependencies, and decide whether they are acceptable for your specific use case. Alright, now that that's out of the way, let's move on to assigning the text in the player_stat script. So you're probably wondering why I'm performing a check to see if the GameManager.instance is now before setting the display of the current stat. This is because when the game first starts, there may be a delay causing the GameManager singleton to not yet be instantiated when the player_stat script is trying to access it, resulting in a null reference exception. Now we are ready to go. Head back into the editor and start the game from the menu. Once in game, pause the game and you should now see that the current stats are displayed. But there's something kinda strange. Why is only the move speed and might value showing while the others are not? Well, that's because we forgot to assign the text when the game begins. Head back into the script and assign all of them in the start method. We're using the start method instead of the awake method for the same reason why we added the null check to the properties. After making the change, hit play again and pause the game to check that all stats and their values are displayed. To check if the real-time aspect of the display is working, resume the game and upgrade your wings and spinach to increase your move speed and might respectively. Then pause the game again to see the changes reflected in the display. Alright, great job. You now have a working real-time stat display in your game. The next game state we'll cover is Game Over, which may seem simple, but there's actually quite a bit that we have to do. In Vampire Survivors, when the player's health reaches 0 and the game ends, they'll see a results screen showing what they have achieved during their run. This screen displays information like the level they reach and the weapons and passive items they use, making it unique. To begin, we'll create a public method called Game Over that will be called when the game's conditions are met to end the game. Inside this method, we'll call the change state method to switch the game state to Game Over. Then we'll create a method called display results to show the various information after the player's run. Next, we need to create a flag to keep track of whether the game is over. Let's call it isGameOver and set its initial value to false. Then, inside the GameOver case block, we can check if the game is not already over by using the isGameOver variable. Now, if it is false, we need to set it to true to indicate that the game has ended. We can also add a debug.log line as an indicator. Finally, we can call the display results method to show the player's achievements. Alright, so checking whether isGameOver is already true before setting it to true is important to prevent the display results function from being executed multiple times. So we all know that the update method is called rapidly, and without this check, it will call the display results multiple times, which can lead to errors or unwanted behavior since, well, it's on update. By checking whether isGameOver is already true before calling the display results method and setting it to true, we can just ensure that the function is only called once. Now, to display the information after the player's death, we need to create a public game object called resultScreen that will act as the result screen. This object will be activated once the game ends inside the display results method. We should also disable the result screen in the disable screens method. Now, let's modify the player stat script. Remove the debug.log line from the kill method and add a check for isGameOver before calling the GameOver method. So we are adding this check because the current implementation of the take damage method calls the kill method, which will end the game even if it is already ended, leading to unwanted behavior. Thus, we just need an extra check. So by adding the isGameOver check, we can just ensure that the GameOver method is only called once and only when the game has ended. As you might have been able to tell already, we could have called the additional condition when calling for the kill method in the take damage function, but since we want to allow for more flexibility, we didn't do so. For example, if we plan to add a revive item in the future, we can modify the kill method without affecting the take damage method. Alright, so now let's go back to the editor and open up the game scene. Under Canvas, Screens, let's create a new panel and name it Result Screen. Set the color of the panel to black and adjust the alpha to make it opaque so that it stands out from the pause screen. Next, drag the result screen panel into the slot of the game manager. Now before we test the game, let's do one very important step, which is to set the health of both characters in their respective scriptable objects to something extremely small like 10. This is such that they can be killed by the enemy in one hit. This will make testing much easier, and yeah, don't worry, I'll provide a reminder at the end to change these values back. Now, when you play the game and collide with an enemy, the result screen should appear and the current state in the inspector should show as Game Over. When you open up your console, you should also be able to see the debug.log line that we added in the Game Over code block. However, we're not finished yet. Let's create a button at the bottom of the result screen called Done, which will bring the player back to the main menu. Alternatively, you can also just duplicate the quit button from the pause screen and change its name and text accordingly. Before we proceed to the next section, let's make some improvements to the game over state. There are two main things that we want to do. First up, we want to freeze time. Similar to how we pause the game, we can freeze time by setting time.timescale to 0. This will stop all actions in the game such as moving characters and other gameplay mechanics, which can help optimize the performance and prevent bugs from occurring after the game ends. The second thing that we want to do is to stop player input. So when the game ends, we should just disable any of the player's input. Although freezing time already stops the input detection, some input detection systems may still work based on events or messages, so it's just important for us to just disable them all manually. To implement the first improvement, simply set time.timescale to 0 after setting the is game over to true in the game manager script. But before we can move on to the second improvement, we first need to address a potential issue with time.timescale. You see, time.timescale is a static variable that retains its value across different scenes, and while this behavior is useful for some purposes, it can cause problems for our game. For instance, if we return to the main menu or restart the game, none of the systems will work as expected because time.timescale is still set to 0. If you're not convinced, you can try playing the game and dying. Then hit the done button to return to the main menu and start a new game. You'll notice that your character can't move because the time.timescale is still set to 0, which halts physics calculations. To fix this, we need to reset the time.timescale when switching scenes. And fortunately, we have the scene controller script which helps us to change scenes and is present in all scenes. Thus, we can just add a line of code to reset the time.timescale after loading a new scene. If you haven't noticed already, our implementation of resetting time.timescale is also beneficial for our pausing mechanic. When players pause and choose to return to the main menu, the time.timescale value will be reset to 1 instead of remaining at 0. Now, let's return to the editor and play the game. When your character dies and you start a new game from the menu, all systems should still be functioning properly. So you might be wondering how this works and why this works because we are setting time.timescale after loading the new scene. Let me explain. So as explained before, time.timescale is a global setting that affects the timescale for the entire application and not just the current scene. So when the scene controller script loads a new scene using the scene-manager.loadScene, setting the time.timescale to 1 immediately after loading the new scene resets the time.timescale value to its default value, so it doesn't really matter. This ensures that the time resumes in the new scene as expected. Now that we have that covered, let's move on to our second improvement, which is stopping the player's input after the player ends. But before we do that, let's do some testing. In the game manager script, comment out the line that enables the results screen in the display results method. Now, when you play the game in the editor and your character dies, you'll notice that although you can't move, your input is still being detected and your character can still change the direction it's facing. To fix this, we need to check if the game is over using the isGameOver bool that we created in the game manager script. Now, in the input management and move methods of the player movement script, we can return immediately if isGameOver is true. Now, when you head back into the editor and test once more, you'll see that the input is no longer being registered after the game ends. Awesome! Remember to uncomment the line that we commented out for testing in the display results method. Now, let's work on displaying some of the game information on the results screen when the game ends. First, let's start planning the information that we want to display on the results screen. Firstly, we should display the name and sprite of the character that the player chose for that run. Then, we can display the level the player reached. Additionally, we can display the weapons and passive items they chose. Some of you may be wondering about the overall time that the player survived at the end of the game. Don't worry, we'll be covering that in a later part. I would also like to mention that how and what you set up your results screen with is entirely up to you. UI is subjective, so I suggest you to explore and experiment with what we'll be covering in this section. Let's start by creating the UI elements for the chosen character's sprite and name. First, create a text object and name it results. Increase the font size and anchor it to the top and align it to the center. Afterwards, create an image object and name it divider. Set its width to 1 and height to 300 to match the look of Vampire Survivors. And then create an empty game object named chosen character holder under the results screen. Anchor it to the right and set its width to 220 and height to 90. Adjust its position to the desired location. Add an image and a text inside a chosen character holder, naming them chosen character image and chosen character name. Adjust their positions to fit inside the character holder, and set the image width to 30 and the height to 60. And finally, just adjust the position of the holder to your desired location. Following these steps should give you a similar result to this. Now, let's add the code to display the chosen character sprite and name. To do this, we need to create two fields in our character scriptable object script: icon for the sprite and name for the character name. Now, when declaring the name field, it's always good practice to add the new keyword in front of string. This is because Unity recommends using a new string name instead of directly using the string variable to avoid accidental modifications of the original value. If you modify a string variable directly, you might just end up changing the original value, which can cause unexpected issues and make debugging more difficult. Onto the game manager. Let's begin by reorganizing the UI header as it's currently too broad, so let's break it down into more specific headers. Afterwards, we need to create a few new elements, including a public image called chosen character image, a public text called chosen character name, and a public method called assign chosen character UI. This method takes in an argument of type character scriptable object called chosen character data and will be called on the player stat script to assign the relevant UI elements. Within this method, we'll simply assign the variables we created to the chosen character's data icon and name respectively. Now, you may be wondering why we are creating a separate method to assign the UI elements instead of just directly referencing the character data of the player stat script in the display results function. Well, this is because of the practice that it is generally not recommended to reference things within the game manager. Directly referencing variables in the game manager from other scripts can create tight coupling between the different parts of the game code. It's generally better to have dependencies and references flow towards the game manager instead of the other way around. Next, we'll head into the player stat script and call this new method in start, passing in the character data. Now, go back to the Unity editor and set up the icon and name fields for both characters. Now, since we don't have different sprites for the characters, we can just use the same sprite for both. For this tutorial, let's use the player sprite sheet _48. Don't forget to assign the chosen character image and chosen character name fields. Once again, when the player dies, you should be able to see the chosen character sprite and name displayed in the UI. Next on the list is creating the UI for the player's level reached. To begin, we need to create the necessary UI elements. First and foremost, we need to start by creating an empty game object and renaming it to level reached holder. Anchor it to the left and set its width to 320 and height to 30. Adjust its position accordingly. Afterwards, within the level reach holder, create two new tags and then name them level reached and level reach display. Move them to opposite ends with the level reach tags anchor all the way to the left and the level reach display anchor all the way to the right, and centering both of them. Align the level reach display to the right. Alright, so now let's duplicate the level reach holder for the time survived and rename all elements and text. So although we will cover the time survived in a later part, adding some UI for it is still beneficial. Reposition the time survived holder to your liking. For instance, I'll place mine above the level reach element, similar to how Vampire Survivors displays theirs. Your UI should now look like this. Now let's dive into the code. Start by opening up the game manager and creating a new variable to hold our display. We'll also add a public method called assignLevelReach that takes in an int argument of level reach data. Inside this method, all we need to do is to set the text of the newly created variable to the passed in level reach data. Now, in the player_stat script, right above where we call the GameOver method in kill, we can call the assignLevelReach UI method and pass in the player's level. We're assigning the player's level reach UI at the end because we want to show the final level that the player reached at the end of their run and not while the starting. Now, inside the editor, we first need to assign the level reach display to the level reach display field in the game manager script. And once this is done, start the game from the menu scene and play until the player levels up a few times. Then, when the player dies, you should see the level reach display showing up on the character's final level. Let's add one final element to the result screen, the chosen weapons and passive items. We'll start by creating some UI for them. To do this, duplicate the inventory slots object and move it underneath the result screen and rename it to weapons and passive items chosen. Afterwards, move this object below the chosen character holder and anchor it to the right with a width and height of 250 and 100 respectively. Feel free to enable all of the image components to make it easier to work with. Here's what mine looks like. Once you're done with the positioning, make sure to disable all of the image components. Let's now dive right into the code. In the Game Manager script, we need to create two lists, Chosen Weapons UI and Chosen Passive Items UI. Now, create a method called assign chosen weapon and passive items UI, which takes in two arguments, chosen weapons data and chosen passive items data, both of which are lists of images. First, we'll add a safeguard to prevent null reference accession errors. We'll check that both input lists have the same length as their data counterparts. That is, chosen weapons data has the same length as chosen weapons UI and chosen passive items data has the same as chosen passive items UI. Now, if either of these conditions are not met, we'll simply log a message and return. Next, we'll assign the data to the UI. We'll start with the chosen weapons. Using a for loop, we'll iterate through each element in the chosen weapons UI list. Now, for each element, we'll check if the corresponding element in the chosen weapons data has a non-null sprite. So if it does, we'll enable the corresponding element in the chosen weapons UI list and set its sprite to the corresponding sprite in chosen weapons data. However, if the sprite is null, we'll disable the corresponding element in the chosen weapons UI. We'll repeat this process for the chosen passive items. Lastly, in the player stat script, just like assigning the level reach UI, call the method and pass in the relevant variables in the kill method. After completing this, go back to the editor and make sure you assign the UI slots to their corresponding fields. Then, start playing, and after the player dies, you should be able to see the chosen weapons and passive items. Excellent. Before finishing up, remember to set both of your character's health back to their initial values. That's all for this part. In this part, we went through how to create a game manager to connect everything we have created thus far. We have also covered how to create some important UI elements for the game, including several add-on features. I hope you all enjoyed the video, and if you want to support what we do, you can actually help us by becoming a patron. This will give you access to the project files for tutorials, like this one, as well as any Patreon exclusive posts on our blog. You can find the link to this in the description below. Any support that you give us will actually go a long way, because currently we are making back about 20 cents for every single dollar that we put into content creation. So your help will actually go a long way to help us make this a sustainable endeavor. So that's all. I'll see you all in the next part. Bye!